Hello again. Welcome to China Manufacturing Decoded, the podcast from the Sofeast group. It's Adrian from the team here, and I'm joined by another guest this month. They're coming thick and fast. It's Paul Adams, who is our senior engineer. Hi, Paul.
Hello, Adrian. How you doing?
I'm good, thank you. How are you?
Very well, thank you. Very well. It's a pleasure being on here, and thank you for inviting me.
Yes, it's been a while. If we go back in the mists of time, I think you're on sort of episode 1, 2, and 3, maybe.
Yeah, very much so. I don't know how many episodes ago that was, but it's a while.
Well, I'll tell you, 146 episodes ago, because we are on episode 146 today, and
Well, there
this
you
is
go.
at the very end
It's
of.
nice to be back.
Yeah, absolutely. Well, as I always say, hopefully we'll get you on to another episode in the future. And just before we kick off, Paul, talk to me just a little bit, because in case our listeners aren't accustomed to you, you're with the Sofeast group, and you have written a bunch of content, such as going into detail about selecting the right types of plastics and things like that. So some really great stuff. But talk to me a bit about your history as an engineer, and then we'll kick it off.
Yeah, good. It's a good introduction, by the way. Excellent.
Thank you.
So, yeah, my background is engineering. I've been engineering since school, really, and I've been in the game ever since. Been working in China since 1996. So I've been around the block a few times, let's say, without giving away my age. But yes, I have created a lot of content with the group, a lot of videos. Those people out there on the YouTube channel and such may have seen my videos
Oh, yeah.
we've created. But I think a lot of the content that's has been very specific to product or material or testing,
Yes.
basically. And that's basically my background as an engineer.
Mm, mm.
Um, so yeah, like I said, I've been focused on manufacturing, product development, and getting products into the marketplace for many years now.
Mhm.
A lot of that has been focused with Western manufacturing processes, with manufacturing technology and partners within China itself. Not just China, but a bit in Asia as well, Malaysia and Singapore back in the day.
Yeah.
But predominantly sort of Chinese suppliers these days. So that's basically my background in a nutshell.
I think it's important, this particular topic, that we have yourself coming on as an engineer, because what we're going to be looking at today are some of the key tests that importers, such as the people that we're normally working with at Sofeast, and a lot of our listeners, I hope, they're likely to need to put their products through. And so it's kind of like the 80-20 rule, right? So it's the 20% of product tests that give probably 80% of the results and benefits that a great many importers are going to get. And so as an engineer, I'd love if you can explain what these key tests are and talk a little bit about the equipment used, what's being tested for, and the benefits that the importer is likely to get from doing this kind of test.
To discuss the 2080 rule, I think is a brilliant idea. Yeah, because there are hundreds and hundreds of tests out there that every product can go through, and every engineer and designer has to consider when developing a product. They need to make sure that the product's safe, is fit for use, as well as being able to pass any certification that is required for various different industries and such. So the tests, it basically is endless. However, what I would like to do today is discuss with you, Adrian, and our listeners, is to go through, I think there's 7 main tests that everyone should consider, and they will probably be considering utilizing these tests throughout the product development, or coming back and checking production quality as they move forward.
Yes.
And I think that's an important
Yeah, good
differentiation. That
point.
it's not just about the product development to start with, but it's ensuring the product quality is being continued to be monitored throughout production.
Yeah, that's a good point. And so these tests that I suppose through your career you've just kept on coming back to, then you mentioned there's seven. So let's go through them one by one. And you're going to talk about, as I say, how they're done and the benefits involved and go into a little bit more detail about each. So if we start with the first one then.
Yeah. I'm not gonna say that the first one's the most important. These are
No.
in no particular order.
Right.
But I'd like to start off on test number one that I always refer to as the tensile test. Now, the tensile test is a pretty important test for any any developer that's working on a new product.
Mm,
They need to make sure that the product or the material itself is strong enough in order for that to um, be suitable in the product itself, in the final product. Now, let's have a look at what the tensile test is all about. So it's all about measuring the strength and the performance of a material. And we do that by applying a tension to a sample piece. It's a set size sample piece, but basically that's put into a machine and into two jaws, and the jaws are separated at a set steady speed. Okay, and during that process of being parted, the jaws are being parted, and it's pulling the sample apart.
mm,
There are there are measurement equipment on the actual sample itself. And what we're doing there is measuring not just the break point, but various different attributes of that material and the sample as it's being pulled apart. So we can look at the elongation. We can look at the elastic stage. Now, there is an elastic stage. If you look at steel, for example, it gets to a point before the yield, what they call the yield point. If you remove that tension, the steel will just return back to its standard shape. All of
mm,
these points within sort of the plotted graph are really important to understand from a design aspect.
mm,
Now, can you imagine if we're building a material and we choose the wrong material? Okay, so the material is strong and brittle, it may not be suitable for a product that needs some sort of flex, or if it's being used in a windy environment, if it's an outside product, for example, that's going to break, it's going to snap, it's going to be dangerous, it's going to fail its function.
yeah.
And likewise, if we've got a very flexible material, right, that is able to comply with some different forces within the elements, that is probably the wrong thing to use if you're building a bridge, for example.
Mm,
It's so you really got to look at the material you're using, and you need to understand the test and the results that it gives you. Okay, so
mm.
that's basically the tensile test and why we're looking at it. So let's have a look at. I just want to quickly explain how to carry out the test itself. Now, I did mention that we're going to put a sample in some jaws and pull it apart, so that's pretty accurate. So as we're doing that, the machine actually pulls and applies a tension to that sample and pulls it apart at a controlled rate until it does actually break.
Mm,
Okay. That machine will then measure the forces applied to that sample throughout that entire process. The machine is then capable of plotting and giving you all the results such that it will give you the stretch, it will give the yield point, it will give you the maximum force applied at the break and the amount of elongation that that material went through. So it's going to give you a lot of information just on that one test called the tensile test. Okay. So and there's very similar standards you need to follow, which I'm not going to go into at the moment, but the standards are there. You need to follow that with respect to the material you're testing needs to be a certain sample size and shape and measurement. So that needs to be complied with as well.
mm.
But the results will give you a lot of information just from this one test. Now, who is going to benefit from that? And I've already mentioned like sort of an outdoor environment. If it's windy, it's no good having something that's brittle because that's just going to break. If you're going to build a bridge, you don't want anything flexible because that's going to, wander up and down. That's no good. So let's have a look at some people that really should be considering using the tensile test during both their product development as well as an ongoing quality control aspect to check and monitor production. First comes to mind is automotive. If you think of this as pretty critical when it comes to component design. So we're looking at any of the engine parts, suspension components, body panels even. Okay, they all need to go through various different tests, and the tensile test is right up there on my list when it comes to sort of automotive. Another obvious one is aerospace. I'm not just talking about spacecraft, but the standard aircraft as well. Another critical product that if you get it wrong, we know the consequences.
Yeah.
So this is we need to make sure that we're ticking the boxes, dotting the I's, crossing the T's when it comes to testing. And tensile test is right up there on a lot of product. Landing gear, for example, wind spars, fuselage, you name it. Everything needs to go through this tensile test to make sure that we've got the right parameters for the material that we're checking.
And you know how much the wings actually bend on even commercial planes when you're on them. That it's a crazy amount, right? So yeah, I can see how
when
how
you
that
look out that window when you're in turbulence, it's a scary thing.
Yeah,
that's right.
Yeah.
So as an engineer, it's your responsibility, to make sure that you are designing a product that is fit for purpose.
Yeah.
Plus a little bit of a sort of safety factor in there. We can't afford to design right to the wire with no room for errors. We always have to design in what we call a safety factor. So we know that the material can withstand the forces that we design to, plus an extra safety factor. Without fear. That's really important to understand. So another one is construction. We were always talking about sort of steel and plastics. Well, I certainly have been for the last many, many years when I've been sort of writing and creating content. But another thing comes to mind is construction. You can actually put various different pieces of concrete or different steel, so we're talking about the rebar and stuff like this. All of that has load-bearing capacity requirements. And again, materials like that can be subjected to the tensile test. So which is really good. Another odd one, if you think about it, is textiles. We can put textile components through there, clothing, footwear, leather, all of these materials need to withstand a certain parameter when you're designing it. When I'm talking about clothing, you could actually put your standard everyday clothing through there. But what about some safety clothing? What about some rock climbing equipment? Things like this,
Well, and you have high performance athletics clothing as well, and certainly things like the sneakers. Those are very highly engineered these days.
Yes, they are. Yes, they are. Yeah, and a lot of people, certainly in my experience, I've used this on a lot of polymers or plastics, a lot of steels and other materials, less so on concrete and wood, to be fair, in my own experience. But again, I just want to bring that to the attention that is a critical component that needs to be tested. And the tensile test is a very good way of getting a lot of data from one test. Packaging and materials is another one, obviously. So we need to have a look at that. So those industries, if you're in that industry or one of these industries, you really should be considering the tensile test when you're looking at choosing a material for any of the components within the design. And remember, this not just at the beginning stage. This really should be taking a product from production and checking the quality to ensure you've got consistency over a period of time. Okay.
Yeah.
So that's a really good thing there.
It's a good one. I suppose there's different ways to perform this test. Is there one type of machine that is typically used?
I was just about to say that, and the beauty of having a tensile test carried out at a lab or an inspection lab is that can be carried out on various different machines. You have a dedicated tensile test machine, but you've also got what we call a universal test machine, or a UTM. Now, the
Mm.
UTM is capable of carrying out more than just the tensile test.
Mm.
Right? It can do a number of different tests, and some of the tests that we're going to be talking about here today can be carried out on the universal test machine. Which,
Okay.
when we get to that point, I'll say, and here is another example where the universal test machine can be utilized to carry out that test.
Nice.
So yeah, we have different options when we come into the actual product or a piece of equipment that we can carry out the tensile test. Most test
Mm.
labs will have a dedicated tensile tester if it's a smaller piece, if they're looking at small components. Generally, the universal test machines are slightly larger, and they're more capable of handling all sorts of different products and materials.
Right.
So yeah, the
That's
universal test machine, that's the thing you're looking for when you go to a test lab to get your products tested.
Yeah, and I was going to make the point about this actually. I don't suppose a lot of importers need to have an extremely in-depth knowledge about the types of machines used for each tests. Of course, they can, but I guess it is important to understand what the lab that you're considering working with is actually capable of. And if they have the correct equipment to do the tests that you need, then that's something, if you know they've got it, then that's a benefit to you.
I think you're right. It's a case of having that conversation with the lab you're choosing, and making sure that they've got the relevant equipment. There's no
Mm.
need for you to know the ins and outs on how it works intimately. You just need to know that they have the correct equipment and they are capable and competent in using that equipment.
Yeah. Okay.
And I
Cool.
think that's a key thing.
Lovely. Okay, that's the first test then. That was the tensile test. So let's move on to number two.
Test number two. I want to talk about the impact test. Now, again, and this is a very relevant test, and I've carried this test out. I've had this test carried out on all sorts of products that I've worked with in the past. And the impact test is basically a test that will show you how your material can withstand a shock impact.
Mm.
Okay, so you imagine if you're in the game of developing bulletproof cars or bulletproof windows, for example, and you choose the wrong material.
Yep.
Again, it's a critical component that you're working with. Yeah, it's a bulletproof. It needs to stop a bullet coming through, and it's protecting the occupants of the car or the vehicle. And you've chosen the wrong vehicle. You've chosen the wrong material, and the product fails, and the occupants are no longer safe. You know, so again, it's something you really need to understand how that material performs under that shock load, right? And the
Mm.
impact test is the way to go. Now, I'm going to talk about one particular machine here, and this is the Sharpie test. This is a very dedicated machine just for this. It's a Sharpie V-notch test machine. There are other machines out there, like the IZOD, which I'll talk about. We'll just mention later. But basically, the industry standard is the Sharpie test machine. Okay, so let me get that one out of the way to start with. And basically how it works, Adrian, is this is a mechanical testing device. Okay, and what we do is we load our sample into a vise, which is located at the bottom of the test machine. And the test machine has a big pendulum. You know, you got like a big anvil that is lifted up and it's let go, and that anvil comes rocketing down on an arc, and it impacts the test piece itself. At which point, the machine will measure how much energy has been absorbed by that specimen. Now, in some cases, it will shatter and break the specimen. Other times, it will just come down and it will resist the weight of the pendulum coming down. It would just bend, or it would just like, you just take up all of the energy from that hammer. Depending, again, this will depend on the material you are testing. Okay, so let's have a quick look at how it works in a little bit more detail. So I've already said there's a test specimen. Sometimes this has a notch, okay, and that notch is there to propagate a crack and actually get that sample to break. Okay, so this is sometimes referred to as the Sharpie notch test for obvious reasons. It's got a notch in the actual sample itself. So once that piece of sample, and a sample can be anything from a piece of metal to a plastic, to a concrete even. So once that is loaded into that vise, the pendulum is set and it comes down, and the force is measured on the sample itself. Okay. It's the resistance of how much force that takes is what is important here. And that is basically what we're doing. So it can be, the sample piece can be damaged. It can have slight cracks in it. It can have a dent. It can totally shatter. Yeah. And again, like I said, it will depend on the material being tested itself. So again, who is going to benefit from the impact test? Manufacturing industries. I'm just going to broad brush the manufacturing industry, where we've got every type of product being manufactured that could potentially have an impact from in use. And I'm talking about something like a lawnmower, for example, where the blades are spinning and it could pick up a stone or a piece of debris and throw that against the housing. Now, if that housing cannot contain that stone, all of a sudden we've got a lethal weapon. So we need to make sure that the product can withstand, or in this case, the housing on the lawnmower could withstand a very high impact force from potentially a sharp stone or a rock that is being forced against that inner housing.
Yeah.
Very critical to do that. Vacuum cleaner, for example, same thing. It might not be as severe, but anything that you could think of that can be used, dropped, hit against something hits against it, all needs to have that relevant piece of information with respect to, is this material good enough to withstand the impact that I could think of during the design to act as a safe product. Okay. And to the extreme, I'll go back to the bulletproof glass. It's polycarbonate is one of the best materials out there, and you'll see this in all sorts of places, banks, jewelry shops, for example. It's if you're choosing the wrong material, you're either putting out a product that's not safe or it's not protecting something. Very, very important to do this. Construction industry as well. We talked about construction industry last time with respect to concrete and bricks. In this case, we're talking a little bit more rounded, more broad brush when it comes to that. We're looking at pipelines, pressure vessels, boilers, for example. Other larger construction industry uses, they all need to have that impact test carried out, because again, this could be a very, very critical component we're looking at. The same when it comes to energy industry, nuclear plants. Can you imagine, how dangerous would that be? Oil and gas industry. Very, very important to understand. You choosing the right material. When you're choosing the right material, you obviously, scale everything up with respect to the thickness of the material that you're using in production itself.
Yeah.
And another two I just want to bring up without going into too much detail is the aerospace, which I've already talked about in the previous one, and research and development industries such as universities or research labs themselves. Very, very interested in gathering data for material and producing white papers for for designers, plug us. Make
Mm,
it very, very useful.
mm.
So that's the Sharp Impact test machine, which is really widely used across the industry to make sure that the material that you've chosen meets the safety requirements that you're designing for.
Yeah, it's good. I think it's also probably one of the tests that we're concerned about when we're considering durability as well. Certainly in some of those industries. I mean, construction, you want to make sure that the materials that you're using are going to be durable for the long term, for example. So
Indeed.
that the ability to resist impacts, for a pipe, for example, that's an obvious one, I suppose. So yeah, I
Yep.
can see how this is a really good one. That's helpful. Yeah. The next one on the list, which is the third one, also it's quite similar in some ways, right?
Test number 3. I want to talk about hardness testing. Yes, it is. It is very similar. But hardness testing is probably, I don't want to say it's the most widely used, but I feel it is. Certainly in my
Okay.
experience. Certainly in my experience, so everything that I've done and touched in the past, I wanted to know how hard it is, for
Mm.
various different reasons. Now the hardness test, I could talk to hardness testing for about an hour. I'm clearly not. I'm going to summarize it from start to finish, I think, on this
Mm.
one. Now, again, it's very similar to impact testing, but hardness testing is a method of checking how hard your material is. In other words, how resistant it is at being scratched or indented.
Mm.
Okay, that's basically a summary of what hardness testing does. So let's have a look at, like I say, I'm going to broad brush this,
Yep.
because there are so many different methods on how to do hardness testing. And this is why I want to broad brush it because I'll be here forever otherwise.
Mm.
So let's have a quick look at how it works. So the hardness it measures the material resistance, like I said, and the resistance to deform and indent. Okay, that's key. Various different methods are Rockwell hardness, Brunel hardness, Vickers hardness, and Shaw hardness. There
Mm.
are others out there, but they're the top ones that I've used in the past and tend to come up to the top when it comes to popularity. Now, these involved applying a force to the surface of the sample or the material being used, and that can include an indenter that is a diamond tip or just a steel ball. Okay. Now, how do we check the hardness? Well, that indenter is pressed down at a determined rate or a force, and then the indentation itself is measured. Okay, from either a cross section area or a depth, and that is then correlated with a set of tables where you get your value.
Mm.
Okay, and the results will be used to determine how suitable your material is to withstand the hardness. In other words, is it good enough for the product you're developing?
Yep.
That's it in a nutshell.
Okay.
Okay, it's very broad brushed on that.
Mm.
Okay, so who's going to benefit the most from using a hardness test and getting the results from that? Well, no surprise there. It's basically the same list. So the manufacturing industries, if you're looking at if you're in the automotive industry, it's really critical that you're choosing the right materials at the right hardness for various different things like gears, ball joints, and things like this,
Mm.
machinery and tooling as well. I don't know how many wrenches wrench stroke spanner, for us English guys. How many sort of wrenches have you actually put on a really stiff bolt and it's just snapped or bent and it just hasn't done its
Mm.
job? You know,
Mm.
choosing the wrong material, and that could easily have been overcome by doing some of these tests. Some of the products out there are really, really critical when it comes to the hardness, especially when it comes to wear factor. And the wear factor is, when you've got two components rubbing against each other to the wrong hardness, it's just going to rub away and wear out. so which is not good.
No.
Construction industry as well. We're looking at various different concretes, ceramics. We're looking at glass as
Mm.
well in this case. All of these materials can be hardness tested to some extent. Medical industry as well. My poor old mum, she's had a number of hip replacements. And we need to
Yeah.
make sure the material going into that somebody's body is not going to wear out after a year. And you
Absolutely.
need
Yeah.
to make
That's a good one.
sure it's got longevity. So we're
Mm.
looking at the right material and making sure it's hard enough and it's the right compatibility with the sort of matching material as well. So the medical industry is another obvious one. Surgical equipment as well.
Yep.
Um, just in the surgery as well as
Mm.
dentist equipment. So a
Mm.
lot of these pieces of equipment really need to be defined with respect to what their hardness is.
Okay.
Aerospace industry, and again, research and development for these white papers, and a lot of industries will be looking for that information.
Nice.
Um, so I just want to quickly sort of go over the four different hardness tests that I mentioned earlier. And the way I want to frame this is go from hard to soft,
Yep.
as it were. So the Vickers hardness test, it is normally used for hard materials such as hard steels, titaniums, um, as well as anything thin and as brittle. Okay. The
Mm.
Rockwell hardness is the next one down, and that's more suitable for a wider range of materials, including hard materials, steels and titanium, as well as some of the softer materials such as aluminum and brass. The Brunel hardness that tends to have a larger ball indentation, and that is generally used. You'll see that being used on castings where it's got a rough surface finish. Okay, so where that larger ball indentation comes down, it's easier to measure on a rough surface,
Right.
such as like a cast iron or an alloy or something like that. And
Mm-hmm.
then you've got the shore hardness testing, which is more suitable for softer materials such as rubbers, elastomers, and other polymers itself. So
Right.
that's basically those four different types of hardness testing machines going from hard to soft. Okay, without
Right.
going into too much detail there.
For more information on those, I do remember you've created some videos on those in our YouTube channel. So, as always, people, please check the show notes. I will be including links to a lot of the stuff that Paul's talking about today.
You're right. It's one of those things that we're broad brushing at the moment and touching on the subject, but I know that we have a lot of detail with respect to each of these in sort of finite detail, how to set it up, how to use it,
Yeah.
and examples of some of the graphs and results and everything like this. So just to finish off,
Hmm.
summarizing the hardness test equipment. So it is really important to use the hardness testing throughout your development and again in production to ensure that you've got consistency in products output from your supplier.
Yeah.
And this will make sure that you've got traceability, and it will determine the suitability of the material for your application itself. It will also monitor any changes that the supplier may be pushing through.
Mm.
This is where another one where I've used this extensively is heat treatment, making sure your heat treatment is correct. Okay, it's
Mm.
particularly on gears and stuff like this. So heat treatment that's a must. That goes hand in hand. The heat treatment products go with hardness testing.
Right.
Like I said, quality control. Making sure that you've got consistency in all of your materials from start to finish.
Okay, and on to the fourth test, please.
Number four test is the flexural test or bend test, however you want to sort of say it, or however
Hmm.
it's referred to in your area. And again, this is another important one for various different industries, but basically, it is as it sounds. It does what it says on the tin, as they say. The
Mm.
flexural test is also known as a bend test, like I've said, and it's a typical mechanical test that's used to determine the flexural strength or the stiffness of a material. Okay, it's normally performed on a beam-like horizontal specimen or a sample. That could either be a bar or a flat bar or a round rod as a specimen, depending on what's a material and the specifications we're looking at. And then a load is applied to the center or multiple points during which, again, measurements are taken and the machine will actually sort of spit out a lot of data
Mm.
for you to determine what that flexural strength is. Okay. So that's basically where we are. And what we're testing here is steel, various different polymers. We're looking at ceramics and composites. Composites has sort of come a long way in the last few years. Never really existed so much when I first started around, but a lot of um, bikes, for example, road bikes or mountain bikes these days are made out of a carbon fiber composite.
Mm.
Yeah, and again, this is something that I've worked on in the past. Where we're looking at a mountain bike, a downhill mountain bike made of carbon fiber composite. The frame was carbon fiber composite, and that really needs to withstand all of the shock and bangs and everything. And the amount of tests that a carbon fiber composite frame goes through is incredible. And one of the important ones there is a flexural test or a bend test. Obviously, it can't bend underneath you. It can't snap because it's too brittle. So, having that flexural test is really important for something like that. And like I said, what we're doing is mounting the sample in the machine, and we're either bringing down the machine head such that we're applying a known force at a particular set rate, and we're trying to bend the sample. And during that process, we are measuring everything that's going on within that sample piece itself.
Mm.
Or there's multiple points, 3 or 4 points that the sample is being pressed or exerted on. And again, this is really important with respect to what material you're looking at in your design for the end product itself. Now, who's going to benefit from that? Like I said, I'm just going to bring out a number of different examples. One that I have worked on in the last few years is that mountain bike. It is a downhill mountain bike. Now, it's really, really critical to understand how much that frame flexed and how much it couldn't flex. The architects, for example, that's another good one where we're looking at that. I mentioned bridges at the beginning of this podcast when we were talking, Adrian.
Mm.
With respect to making sure that you've got the right material. Bridge material, generally steel, good quality steel, needs to go through this particular test to ensure, we've got the right parameters.
Sure.
There's no good having some of these bridges wobbling up and down and tipping cars off. They need to be right. We've all seen the videos, the magic bridge that was swaying needs to be correct. And again, quality control. I keep on going on about this because it's so important, Adrian, and I can't stress it enough that particularly when you are dealing with the supply chain, when you are in sort of the Western hemisphere somewhere, so the States, for example, and you are bringing in your products from China, you need to ensure that you've got consistency, and consistency is maintained by testing products from production. And you really got to do that. It's really important. I've seen that time and time again in all of my years working with different suppliers. So a flexural test, it is really good to have in your arsenal of tests to actually look at, am I using the right product material? Now, let's have a look at the machine itself. We're going to go back to our friend, the UTM, the Universal Test Machine, because this machine, if you've got one of these, it is capable of doing this. It's got the tensile section. In other words, it can pull. It can also push. Okay, and pushing is what we're doing here with respect to the flexural test. And again, it's really good to understand if your test lab has the Universal Test Machine, because you know that they will be able to carry out a number of critical tests for you on various different components, tests, and production items. So, which is good. Again, there's some of the materials we're looking at is various different polymers, thermoplastics, and thermosets. So, which is really important. And again, we've got more information in depth on some of the content we've already written out there. Ceramics, glasses, fiber reinforced plastics. I've already talked about sort of the carbon fiber bike frame. All of these materials can go through this test, and everybody that's so many industries that use various different materials that need to understand how much their material flexes. It's no good having a material that flexes too much. So you need to understand, if you're designing a product that needs to be compliant, or when I'm talking about compliant, it needs to move. So you need to understand it can have that movement you're designing without going past that, because that's a failure point, as well as making sure, on the other hand, that the product does not flex. So again, we're looking at two ends of the spectrum with respect to having the results analyzed with respect to what your material can do and what you are designing it to do. Another good one, just throw that in there, prosthetic limbs. Okay. You don't want them bending from underneath you, but you also want them a little bit compliant in order for them to be comfortable as you're moving, if we're talking about a prosthetic leg, for example. So that's a flexural test. Next one I want to talk about, Adrian, is test number 5, which is chemical analysis. Now, when I'm talking about chemical analysis, I'm not talking about something like bleach or something like this. It's more of a chemical composition of a material.
Right.
Okay, so it's very. I just want to make that clear. It's the chemical composition of a material, and this is vitally important when it comes to designing and development of products, in particularly metals. Okay. So the chemical composition is the mechanical, that's the physical and mechanical properties of the material, which gives it its strength, ductility, thermal conductivity, and electrical conductivity. So we need to ensure that we're choosing the right material. And one way to do that is through chemical analysis. Now, luckily, there are a number of devices out there, and one which is my go-to favorite, which is the XRF, okay, which is the X-ray fluorescence machine or alloy analyzer. Now, these are brilliant. Now, you can get them in various different sizes. You can get the bench size. In other words, it's permanently affixed to a bench in a lab. Or, more importantly, is the portable handheld analyzer, where your factory auditor or an inspector can go to the location and physically check the samples prior to manufacturing. Okay, that's priceless, absolutely priceless. Because you can get the results of what material they are planning to use before they actually use it, to ensure that that is what you've actually ordered, because you've already done the design work, you've already done the testing, you've actually worked out exactly what material you want. And one way to double check that is to use the analyzer on it prior to any production work, because that way you're not going to waste any money, they're not going to waste time and money, and it can be rectified very easily by changing out the wrong material to the right material. Now you're saying, how the hell does that work? You know, it's simple, really. It's X-ray. So basically, let me try and explain how this works as a either as a benchtop or as a handheld device. Now, this is a non-destructive process, and what happens is the the gun will be, I'm calling it a gun, it's a device that will be fired off at the material surface, and it's the X-ray beam will excite the elements within the material itself, and the responding response, the beam coming back into the machine itself, will give you how much of each of the elements is within that material itself, and it will give you a quick readout on the display, either on the handheld device or on a larger monitor if it's the bench mounted sort of product, and that will give you exactly the amount of elements that make up that material. And again, this is priceless if you're looking at a very, very critical material for a safety critical product, for example. Okay.
Mm.
Another way that this is very commonly used, unfortunately, is in fault finding, where I talked about earlier, is very, very useful if your inspector or auditor can go to the factory and check the material before it's being used for processing any product. Unfortunately, a lot of people come to us or other agencies with respect to I've got a problem. My product is failed, and I don't know why. The manufacturing guys have said everything's okay, the materials X, Y, Z, and here's the certificate to show it. So one thing we'll do is have a look at the analysis from the X-ray itself, the analyzer, and then we can determine whether that material is to specification or is outside the specification. Unfortunately, a lot of the times these are used in fault finding cases where the product's already failed and it's too late. But it gives you a concrete evidence, because it basically is a very, very accurate method of choosing or selecting the material, and it gives you that bulletproof sort of result, as it were. It is finite. That's it. So again, we're looking at who's going to benefit from this. Well, if you've got a safety critical product, or if you're really conscious about the material you're using has to be correct within an absolute finite window specification, you need to use this. You need to use it. If you've got a product that has failed, this is a very, very good way to check to see if that material is meeting specification. Okay.
Right.
And again, I've used this in the past at the front end, checking and verifying the material is correct in the manufacturer. And unfortunately, I've been had to use it at the back end when the product's failed. And indeed, the material was out of specification, despite the certificate showing it was correct. So again, it's very good if your inspection lab or inspection company that you're working with has one of these in their portfolio. Very, very good to have.
Yes.
Some quick summary on this one is that the handheld devices are very, very useful to have. Use them at start of production, because that will save a lot of time, effort, and money. And they can be used as continuous quality check and performance on the material that is being used in your supplier. Very, very easy to test, non-destructive, very easy to do, and very critical.
Yeah, we hope the supplier isn't going to use a material that is out of specification, but it could happen either by a mistake somewhere in the supply chain or somebody's trying to pull a fast one. So yeah, I can see how that's a really good one.
Yeah, you're right. Yeah, either way, it's trying to get to the bottom line. There's a root cause analysis, as I say.
Yep.
We've really got to get to the bottom of it, and hopefully, no one's trying to pull a fast one. But genuine mistakes do happen. But this is one way to overcome that. So which is good.
All right,
So
very
that
good.
covers that one. Test number 6, I would like to talk about fatigue testing. Okay, so I'm not talking about tiredness. I'm talking about how long your product will last. Okay, this is all about the fatigue of the material itself. Now, to put it another way, right? This involves repeatedly loading and unloading material or a component multiple times through a cyclic stress process, if that makes sense. Okay. So the goal here is to understand whether your product will fail or whether it has got longevity plus that safety factor we talked about earlier. Because if there's something that's going to fail, you need to understand before it gets to production. Okay. And having a fatigue test during your design and development phase, I think is really, really important.
Yeah.
Now, the way this works is, again, we're going to go back to our friend, the Universal Test Machine. It's a brilliant machine. I think every lab should have one because it does so much. And the fatigue test is one of those things that it can actually do. Now, very, very quick points on how to carry out the fatigue test is, to start with, you need to understand how many cycles your product is going to flex, let's say, throughout its life cycle, plus that safety factor we keep talking about. And that is what you plug into your test machine. In other words, 1,000,000 cycles, for example. It needs to flex 1,000,000 cycles because I know that's going to last 10 years in service. That's fine. You plug that into there, and the machine will go off and it will do 1,000,000 cycles. And during those cycles, what it's doing is applying a force. So it's forcing the product down and then releasing that force so it flexes back up. You can then go further, and so it's double flexing. So you can pull it back up or move it from left to right, depending on the orientation, instead of just flexing it one way and then let the material sample come back to the center. You're actually flexing it both ways. Okay, so depending on what your product is designed to do, you would either set the machine up to do a single flex or a double flex. Okay, and it would go off and it would do all of those cycles. During those cycles, obviously, the machine is recording all of the actions and activities of what's going on with your sample, and you will be able to print off that and have a look at all of the cyclic information with respect to the forces going into the product and whether there's any early signs of failure, whether that product's being damaged, whether that is any cracks or damages on the product itself. And again, you'll be able to understand this because that machine is recording and analyzing all the time throughout that test.
Yeah.
So I just want to look at some critical components. I'll be trying to give some examples, like the sort of the mountain bike and the previous one in flexing. Can you imagine something like a wind turbine in this case? This is a big piece of engineering going on here. Wind turbines. Absolutely critical. I did work for there's a company in my hometown in Colchester, the UK, way back. They've gone out of business now, but they used to make extraction fans for tunnels, car tunnels. And one of the things that they always used to talk about is absolutely critical that these blades were did not fatigue. It was one of the big things that they were talking about. They had to go through these tests all of the time. Could you imagine one of these blades spinning around and that fails? It's all of a sudden you've got a potential deadly lethal missile coming towards you in a tunnel, it's
Yep.
going to cause chaos. So again, yeah, a lot of industries, a lot of products are going to benefit from this. The sort of the vacuum cleaner, the spinning blades in a blender or a juicer. That's what I'm trying to think of. Stuff like this, it's like it's not just the strength, but it's the flexibility, and it's the sort of the failure mode from all of these cyclic actions is going to go through it. The fatigue is going to go through. You need to make sure the product you're designing has the correct material that can withstand the test of time. And the fatigue test is one of those tests that should be done, basically. It should be done in so many different industries.
Our head of new product development, Andrew, really talks a lot about product reliability and durability. And he's been on the podcast before talking about this and written a lot of good stuff about it, actually, on Gillian's blog as well, our contract manufacturing subsidiaries blog. And I suppose that when it comes to reliability and durability, this is really one of the sort of key tests that would be used, because when you think about it, if we just pick up our phone or we're using our laptop, and we don't think about how many times we're hitting the keys or we're powering it up or we're plugging things into it. But behind every product, when it's being developed, you want to make sure that your product is going to have the correct lifetime that's appropriate for your unique needs, right? And it's going to at least last through the warranty period, for example. So I suppose in the development of the product, this type of test is really going to be extremely useful for making sure that your product is going to have that lifetime.
Yeah, exactly. Yeah, and every product's different. I'm just looking at my laptop now, so I very rarely close that, unless I go out and about.
Right.
But a lot of people do. A lot of people open and shut their laptop multiple times a day. And that obviously can't be on a set machine. So it's the fatigue testing more often than not has to have a specific jig or a rig created and developed in order to carry out the test itself.
Yeah.
So that's a lot of the time. But yeah, products need to last,
Absolutely.
Need to last.
Well, if you want to avoid the dreaded product return rate creeping up. So, yeah.
Yeah, indeed. Yeah, we've all seen that in the past. Yeah.
Right. Good.
All right. We're near the end. Let's talk about test number 7. I'm going to talk about creep test. Okay. Now, again, this is one that I've used a lot, particularly on polymers and plastics. Okay, this is where I've done a lot of my cutting my teeth from product development. And a creep test is basically a mechanical test that is determined how long basically the stretch is going to be over a period of time. Yeah, in a product, or the deformation of a material under a constant load. That's a better way of putting it, I guess. And again, this is predominantly I've used it, me personally, I'm talking about personal experience now, on a lot of plastics and polymers that I've developed products with in the past. It can obviously be used on other products as well, such as metals, aluminums, brass, and things like this. But creep is a real thing. It's a real thing, Adrian. If you're looking at a product and you need it to maintain its tolerance over a period of time, because it's a critical component, or you don't want it to go out of shape. You don't want that to creep from a dimensional point of view. Now, a lot of times, products are used in an assembly, as a combined load on various different components or points or joints in an assembly. And sometimes, the load on one component can put more force than you think, or you're designing on the other component. And therefore, over a long period of time, that force is going to have an effect. Right? And that could actually cause creep, what we call creep in the product itself. Now, that creep is basically going to result in failure, because if you've got a ball joint, for example, and this ball joint is created from plastic, so there's two plastic components, and something's not quite aligned in the assembly, even though you've designed everything right, you've got something not quite aligned in the assembly for whatever reason. And the ball itself is putting more force over a long period of time on the cup or the joint or the reciprocal point of the joint. And over a period of time, that's going to deform that cup. The ball is going to force that cup out of shape. And ultimately, what can happen is that ball joint could come apart. That ball could pop out of that cup, for example, because it's the material's crept over a period of time because of that additional force, because of the misalignment in the assembly down the line somewhere. That could be a critical component. Could be. And if it is, it's a serious implication, on the product. So we really need to understand what is creep testing. How can we do creep testing? Well, again, we're going to go back to our friend, the universal test machine, because we can do that. We can load up our sample, and we can generate a constant load. In other words, what we're going to do is pull this sample apart at a constant load and leave it there. And what should happen is nothing. Okay, the result should stay static. The graph should be a flat line in effect. If it's something different, that means that we've got a problem, because that material is creeping over a period of time under that constant force. In other words, the material is incorrect for the design specification. And that is where we need to go back and say, okay, we've got, it's too ductile. Basically, it's too soft. It stretches too much, too easily, too quickly over a period of time. And that is basically what we're testing here when we're talking about creep test.
Okay.
Again, like I said, I've done it on polymers and plastics, but again, it can be done on metals of all sorts. And it tests the ductility of a material over a period of time. So that's basically where we are on that. Again, some sort of real life examples of that could be gears, plastic gears. Okay, I've seen this in a gearbox. A gearbox was on a stair lift, believe it or not. Another one of the industries that I've worked in the past. And everything was all right. However, the material that was chosen for one of the critical gears, in this particular case, the product failed because the product was not actually used in its entirety, what it was designed to do. In other words, transport people from the top of the stairs down to the bottom, from the bottom to the top. This particular person was using it to transport heavier items than people, goods of some description. And basically what they'd done is they left the heavy goods, I don't know what it was, but maybe a load of weights or whatever, I don't know what it was. But they left them on the stair lift for a long period of time. Yeah, so imagine it's like getting someone like me, I'm a heavy guy, but if I sat there for a whole year, then potentially we've got a situation where that gear is being held against the opposite gear, and it crept over a period of time and failed. So not really in the, okay, it was designed to do this realm. However, we still had a failure, and it was down to this creep scenario. So that's a real life sort of scenario that I have actually looked at. And again, we're looking at all sorts of medical products. We're looking at consumer products come to mind. I've done an awful lot of consumer products in my time, sporting goods as well. What we don't want to be doing is getting a product that is too ductile, in other words, too soft, and it creeps over a period of time. That's critical. So, like I said, the how to test this is a universal test machine is one way. There is a dedicated sort of creep test machine for this, but it's 9 times out of 10. When you're doing a tensile test, you can do a creep test. Okay, similar type of mechanism that is used to do these tests. So I think that's sort of the creep test in a nutshell. Adrian, and
Yeah.
I think that concludes my list. Now, I just want to say there are hundreds of different tests out there that can be done, need to be done on certain products. When you're designing a product, when you're developing a product, you need to ensure that you are doing your own research and making sure that you are responsible for picking the right tests such that you're verifying the right material in order to go into your product that will meet various different specifications and regulations if required.
Yes, but given that these are some of the most common that certainly you've had experience with in your quite long career, and we're sort of focusing on the 80-20 rule here. So it's the key tests that provide the most benefits for the most importers. Hopefully, everyone that's listening, these tests will be, at least some of them will be a really good starting point for the types of tests that you want to be using during the development and subsequent manufacturing of your products. I've really loved this today. That's about an hour or so on the sort of tests that people really need to know about and why and how they're beneficial. So useful stuff, Paul.
Great. It's like I said, this, even though it was an hour long, it was as a very cut down short version of the 20, in my opinion, the 20-80 rule, and as Adrian said, and these are critical. So I just want to recap. We've got the tensile test. We've got the impact test. We've got the hardness test, multiple variations of that. We've got the flex test, the chemical analysis, make sure your material is correct, fatigue test, and your creep test. Make sure you put these down on your notepad, wherever you're going to put it. Make sure that you are utilizing these tests because you will benefit from carrying these out.
Excellent. And there you go. That's a great summary to end off the episode. Paul, it's been a pleasure. Let's get you back onto the podcast soon. And to everybody listening, thanks for being with us once again. If you do have any questions about this kind of product testing and the tests specifically that Paul has outlined today, absolutely get in touch with us. You know where to go, sofeast.com, and we'll be happy to talk with you about testing. Indeed, we do help with these sorts of tests, but look, we're absolutely happy to give some friendly advice. So that's the end of today. We'll be back next week with another episode. Thanks again, Paul.
Thanks, Adrian. Bye, everybody.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.